Hello everyone, welcome to my YouTube channel. I am Vinay BK, Assistant Professor, Department of Electrical and Electronics Engineering, Srinivas Institute of Technology, Walchin, Mangalore. In this video, we are going to discuss about a special machine which will be used, the applications you heard like fans, blowers, lathe machines, and drilling machines. And also you all are very familiar with the cranes and elevators. The motor behind this application is DC motor. So in this video, I'm going to talk about a DC motor and a working principle of DC motor. So you all heard about DC motor, which stands for DC direct current and motors. Before going to start with this concept, we should know the difference between motors and generators. And in my previous videos, I was explained about a generator as well as a DC generator. So we all familiar with that. So generator which is used to convert mechanical energy into electrical energy. So DC generator means the output is a DC, so that we can say it as a DC generator. Similarly, before going to start with the DC motor, first we should know that the definition of motor which is defined by which converts electrical energy into mechanical energy, which means that input is electrical, that is DC. If the input is DC supply, then we can say it as a DC motor. If the input is AC supply, then we can say it as AC motor. So in general, we can call a motor is a device which is used to convert electrical energy into mechanical energy. So here we're going to discuss about a DC motor. The working principle of DC motor. Now, before we start with a working principle, there are two main constructional parts in DC motor as explained in my previous videos. So the main parts are, one is a stationary part of motor, we can call this as stator, and rotating part of a motor we can call it as rotor. Explained each and every parts of DC motor as well as DC generator in my previous video. That's constructional features of DC machine. You can go through that and just see what and all the parts which we have, which having and functions of each part I had explained. So here two main parts. One is stator, other one is a rotor. Stator is nothing but a stationary part where we can say it as a field winding which act as a stator and armature winding which act as rotor. I'll repeat once. Field is nothing but stator, armature is nothing but rotor. So now we can go for the working principle of DC motor, which states that when a current carrying conductor is placed in a magnetic field, it experiences mechanical force. So here the working principle, whenever a current carrying conductor is placed in a magnetic field, where the magnetic field which produces in between magnet. So we can say it as a current carrying conductor is nothing but our rotor of DC motor. Can say it as armature is a current carrying conductor, and here the stator also field windings which will be having. So when a current carrying conductor is placed in a magnetic field, it experiences a mechanical force. The direction of mechanical force is given by Fleming's left hand thumb rule. As we all know, the Fleming's left hand thumb rule states that, so by keeping a forefinger and second finger and the thumb, by keeping perpendicular to each other, the thumb represents the direction of force and forefinger represents the direction of magnetic field, as well as a middle finger which gives a direction of current, that is induced current. So if you want to get a direction of force, we can use Fleming's left hand thumb rule. It is given by F equals to BIL newtons. Here B is nothing but flux density, I is nothing but current, and L is nothing but length. Let us I'm going to describe how the mechanical force which experiences in a DC motor by taking an example. So now I'll take a current carrying conductor. According to statement, I'll be explaining here when a current carrying conductor is nothing but of iron. If you'll be using the magnets means the carrying conductor is nothing but iron. Here, the current carrying conductor which is placed between two poles, say it as North Pole and South Pole. So which states that when a current carrying conductor is placed in a magnetic field between North Pole and South Pole, so this conductor which experiences a mechanical force, how it produces a force or twisting a force, you can say it as a torque. So now there are two parts in DC motor, as I told. One is the stator, the one is the rotor. So this north pole and south pole which act as a stator. So due to this stator, the supply is given to the stator, which gives what magnetic field. The magnetic field which has a direction from north pole to south pole. Here we'll be placing the conductor so that it is nothing but armature conductors. Also, as I told, the current carrying conductor is nothing but rotating part, that is armature, so that once the flux which produced by current carrying conductor. So now I'm going to give supply to this current carrying conductor. So when a supply is given to this current carrying conductor, which is also produces a flux. So now there are two fluxes. One is a main flux that is due to field winding due to this north pole and south pole, and the one is the flux which produced in current carrying conductor by giving the external supply. So that the flux which produced by the field when you can call it as main flux, the flux which produced by the current carrying conductor is nothing but rotor flux. So due to these two different fluxes, two currents which induces. So now we'll be going to check the interaction between two fluxes which produced in rotor and stator. So now the direction of flux is clockwise. This direction of flux which you can get it from Lorentz law. So according to Lorentz law, we can get the direction of flux either if current is towards a, if the current is towards a paper, as you are saying, towards a screen. If the current is flowing towards the screen, then a flux direction is clockwise. If the current direction is towards you, then direction of flux will be anti-clockwise. So that is nothing but Lorentz here. So I am assuming current direction is towards the screen, so that which gives the direction of flux in clockwise. So now there are two flux. One is the flux which produced by armature, that is a clockwise direction, and flux we know that is produced by the field winding which travels from north pole to south pole. So there are two halves by using this conductor. On your left side, the direction of flux which produced by armature, also rotor, which is same in the direction of flux which is produced by the field winding. So that there will be addition of flux, so there will be a gathering of flux in left side. Similarly, just check in right side. So here the direction of flux which produced by rotor or else armature current carrying conductor is downward, and the flux which produced in field winding is upward. So the direction of flux are opposite direction, so that there will be cancellation of the flux. So on the right side there will be cancellation of the flux, so that there is no flux on right side. So now we can check the interaction of the flux. On the left side, the gathering of the flux, that is addition of flux. On the right side, there will be a cancellation of the flux. So that here, the gathering of the flux is nothing but here the magnetic flux density is high. On your right side, the magnetic flux density is low. So that the force or else the torque which produced, we try to push the conductor, it which try to push the armature conductors from high magnetic flux density area to low magnetic flux density area. Okay, so that the direction of force is from high magnetic flux density area to low magnetic flux density area, so that the once it starts to push the conductors with the help of torque, the rotor conductors starts to rotate in DC motor, hence the rotor starts to rotate. So this is a working principle of DC motor, that is whenever a current carrying conductor is placed in a magnetic field, it experiences a mechanical force. So you can see here Then on the north pole side, uh, here the field here the direction of force is from high magnetic flux density area to low magnetic flux density area. You can observe here also high magnetic flux density area to low magnetic flux density area, so that the conductor starts to rotate, so that the rotor starts to rotate. So this is a working principle of DC motor. Thank you one and all. Please do like and subscribe to my channel if you are satisfied with this video. Thank you one and all.